Alright, so continuing with logs and antilogs. With an antilog, what is the value of the base raised to the nth power? So to determine the antilog of a number, you have x, the base, to an exponent equals what? That's the same thing as saying antilog base n. So 10 to the third equals 1,000 is the same as saying antilog 10 to the third power equals 1,000. We have a table on the left with the base 2 and on the right with a base 10. The bases are always going to be either 2 or 10, and with hearing we use 10. So we have two exponential series based on a base of 2 and a base of 10. What is 2 raised to the 0, 1, 2, 3, fourth power, or what is 10 raised to the 0, 1, 2, 3, fourth power? Generally, what is the value of the base raised to an nth power? This is the same thing as determining the antilog of a number. Thus, x to the n equals a value is the same as saying antilog x to an exponent equals a value. 2 to the fifth equals 32. Antilog 2 to the fifth equals 32. So with an antilog, you're solving for the answer. 2, 6, 2 raised to the sixth power. Antilog 10, 5, a base of 10 raised to the fifth power. Or with the negative number, remember you divide. Antilog 10 to the 0, a base to 0 equals 1. Antilog 10 to the 1, a base to 1 equals that base. Now with a log, what you're doing is you are solving for the exponent. So you're given the answer, but you're solving for the exponent, okay? So with an antilog, you're given the base and the exponent, and you solve the answer. With a log, you're given the base, and you're given the answer, and you have to determine the exponent. So again, we have a base of 2 and a base of 10, but this time, we don't know what the exponents are. So log 210 equals 3. It's the same thing as saying 2 to what power equals 8. If you look at the scale, go to the scale where 2 is the base, where the answer is 8. The value solved is 8. The exponent that takes 2 to a value of 8 is 3. Log 10, 10,000. Go to the base scale with 10. 10 to what power equals 10,000? 10 to the fourth power equals 10,000. To what power must the base be raised to equal the number? That is the log. You're solving for the answer. When you're solving bases or logs, remember the base must always be specified, and 2 and 10 are our most common bases. So, in summary, if you're taking the log of a number, you are solving for an exponent. An exponent is a log, and a log is an exponent. 10, log 10, 121 equals 2.08279. What does that mean? It means 10 raised to the 2.08279th power equals 121. With the components of a log, you're always going to have an integer, which is a whole number, and then a string of decimal values. The first two answers are obvious. The second one, log to what exponent equals 150. We know we have an integer between 2 and 3. The integer is 2. Then there's a string of decimal points. So with these complicated logs, you're going to have an integer and then a string of decimal values. The integer is called the characteristic. The decimal value is called the mantissa.